It says here, lines, so there are two lines, lines L and M are drawn on the square grid, right? And you're seeing them. Looking at your grid, you're looking at the lines. They're already. All right, let's see what they're asking. It says write down the coordinates of the x-intercept. Well, knowing the meaning of the word is important. X-intercept. An intercept is where something crosses something. So the x-intercept will be here, right? That's the x-intercept for the line L. Crosses the x-axis. They want us to write down the coordinate, so I could simply say the coordinate, and don't make a mistake here, is when you name the x value first, followed by the y value. So I will highlight, try to show you. The x value here is 6, yeah? And the y value, this is where y is 0, all right? So 6 means 0 here, so this is 6, 0. So they're giving you 1 mark to write 6, 0 here. So you do that, you move on. So don't overthink, don't overstress. Read, take your time, flow through.
Sir,
Go ahead, I'm listening.
you say when you're in the coordinates, you must write the x-axis number first before the y?
All the time, every time.
Okay, sir, thanks.
All right, very good. Coordinates are written like this, x, then y. Good. And just for a teachable moment, I'll highlight something. If this is the point, this is the x number, number 4 here, and this is the y number. So we'll call this 4 meets 3. You have to read this one, then that one. So that is how the world has already set up coordinates. So you can't do otherwise. People will have wrong understanding. So for conventional purposes, we have to embrace that, right? All right, we want to know the y-intercept for M, the y-intercept for M. So the line M, we're seeing it. Let me highlight M here. So the y-intercept is right here. And is the coordinate the one? Same principle. So the x value here, this is 0 for the x, and this is -2 for the y. So don't mix up the ideas. All right, so for this one, it is 0 meets -2. There it is. All right, so let's write that. 0 meets -2. You get the mark and you're gone. All right, so they are testing, right? Let me take myself off the screen for a minute. I'm going to close my camera.
You can go back a little bit.
I will. Give me a minute. I will. Hold on. All right. Let me minimize this. All right. Put this right there. Very good. You're seeing now? Are you okay? Kevin?
Yes, sir.
All right. All right. So let's follow the questions. The next question says here, the equation of the line L is x plus 2y minus 6 equals 0. Find the value of k given that the point 9k lies on the line. I want you to note a very important idea here. If I have a line and the equation of this line says y is equal to 3x minus 1. If I find multiple points on this line, multiple, doesn't matter how many I want to find. If the points are on the line, if I should take the x value, let us say that, I'm just making up something just to discuss, and then I've got to do what we do. Let us say this is 1, 4, this point here. This is an x and that's a y. If I should put number 1 where the x is and work out the maths, it's going to tell me the y value. That's what the equation of the line is equipped to do. As long as the point is on that line, if you take the x value and plug it where x is and work out the maths, it's going to tell you the y value. And then vice versa. If you take the y value and put it in and try to work it out, you can find the x value. As long as it is on the line, you'll get the truth. If it is not on the line, you won't get the truth. So they are telling us now that, hey, this point is on the line.
Sir,
I'm listening. Go ahead.
can you go back a little bit up to write off the equation, sir?
It is on, this is the equation.
No, sir, the number A, sir, A.
Oh, you're not writing an equation. What equation are you writing? You're sure there's no, we didn't get any equation up here?
Oh, okay, sir. I thought there was a
No.
equation, right? Okay, sir.
No, man, this is it. So the question is here. The equation of the line L is, they told you, this is it. Now, they had said that the point 9K is on the line, and you're supposed to find K. All you're going to do is to do what we just said. I'm going to take the X value and substitute it. See them there? So then, this is the equation for the line. It says X plus 2Y minus 6 is 0. I can use this to find points that are on that line. So you see the 9, I'm going to put the 9 for X, and I'm going to put K for Y. Because since they asked me to find K, I'm going to put K there so that when I'm working it out, I'll see K coming out. So we're going to substitute. So in other words then, 9 plus 2 times Y, but Y is K, so I'm going to put K. Minus 6, and this is 0. Very straightforward setting up. See there? Very straightforward. Substituting these. Then you solve for K. Solve for K, man. We could just relax, put together our numbers. 9 minus 6 will give a positive 3. Right? So the 9 with a minus 6 is a 3 right there. And this is equal to 0. We're almost there. I need to find K. So I would want to subtract 3 regular from both sides. So I'll have 2K equal to negative 3. Then to find K, I divide by 2. So K is equal to negative 3 over 2. So this is rest on the fact that if a point is on the line, you can substitute one known value to get the other unknown. Just like that. Not a problem. Don't overthink it. Just learn that you are able to do that. Make a note. And if they should send a question like this, we don't know, you can approach it like this. What it means, you know, if they claim that this is on the line, they could ask the question another way. You can test to see if points are on a line. Because if I have a point that is 2, 5, and I plug in 2, and I did not get 5, it means that it's not on the line. You need to understand that's what it means. That's all. All right, let's look at the next piece of the question. Daily, we are at 4, 5, 6, those papers. All right. Find the equation of the line M in the form y equal to mx plus c. So in other words then, can you let the y be by itself? That's what they're asking. So let us write back what it is. It is x plus 2y minus 6 equals 0. But they are saying oh, it's M, it's not M. This is the L1. Let's go for M, not that one. M, let me mark it where it is. Find the equation of M. All right, let's go for M. Looking at M, guys, M. All right. Pay attention to this one, M. Now, whenever you're going to do the equation of a line, you need two things. We need gradient, and you need, so gradient is what we call M, and you need y-intercept, and we call that C. Luckily for M, the y-intercept, see here, it's -2. So we already know that. We know that it's -2. The line crossed the y-axis at -2. So all we need to do is to work out M. Now, you can do more than one things to work out M or to see the value of M. You could look at this. If you're able to pick off a very good right angle triangle, look where the points I'm making there. Look at this. I'm able to see a good enough right angle triangle. See there? There are many. See even one more here. See another one here. You see how many of them are there? I mean, and I'm referring to, so I don't need so many, you know. I'm just showing you that it's all over the thing. So I'm just picking one, and you can pick bigger ones. Look, see a big one here. See there? I only need to pick one. I'm just going to use the two of them to show you that you get the same answer, but I only need one. So let's take a look. When you can pick off triangles where you're able to see the vertical and the horizontal sides clearly. For example, I am seeing that the vertical side here is 2 units and the horizontal side here is 1 unit. Then remember that gradient is equal to rise over run, which is your vertical side over your horizontal side. So the gradient in this case is 2. Let us say that I never saw that triangle and I saw a bigger triangle. Check the big one. This side length is 4. Check it, it's 4 units long. And the short one down here is 2. The vertical, horizontal, vertical is 4, horizontal is 2. So if you were working it out with those numbers, vertical 4 divided by horizontal 2, I still get the same answer. The gradient is 2. So now I'm saying that you're able to do those, man. You can pick up those easily along the way. So then there is no big working out for this. The gradient is 2, the y-intercept is -2. So M is 2, the y-intercept is -2. I could write it in this format by saying y is equal to, instead of putting M now, I'm going to put 2 with the x. And instead of putting the C, I'll put the number for it. That's it. That's what they wanted to do for that question. So it's y equal to 2x minus 2. And you're done with that. Any question pertaining to that? All right. Let's continue looking at more. Show by calculation that line L and M are perpendicular. Now, this is something that you need to make note of. This. When lines are perpendicular, there is a specific thing that happens. I will write it for you because I want you to make note. So I'll write it for you. When lines are perpendicular, the product
The same, sir.
of, give me a minute, the product of their gradient is -1. Jody, Rodney, what were you saying now? Listening now.
No, sir, I thought it was the other one. It's okay.
Okay. Oh, I just realized what you said. You said they are the same. Okay. So when lines are perpendicular, the product of the, oh, this there doesn't spell right. The product of their gradient is -1. No, that's not the answer. That is something that I'm telling you, that this is what you want to show. So this is notes, because they never asked you that, but this is something that you need to know. No, we're talking about, so let me call them line L gradient and line M gradient. We need to go for them, but we know one already. Line M gradient is 2. We just saw that. So we need to know what is line L's gradient. So we know the gradient for line M. See it here? It's 2. So we're going for line L. So we want to find it. Let me clear this diagram again. Clear this up properly. All right. So for line L, the thing is now you can calculate it if you want. See it here? Let us say, can we look at a counting method? So let us look at a calculation method, please. So this was a 6, 0 here. And you will know that this is a 0, 3 here. I'm just saying. So let me do another method now. We're not counting. And you have to bear in mind the shape of the line tell you if the gradient is positive or negative. Please note that. All positive. So let me just say this again for, look at this, just for notes. All positive gradients, the lines are going uphill like that, uphill. Those gradients are always positive. But if you see a line that's set like this, remember that the gradient is always negative. So these are negative gradients. It's like you're going down a hill from left to right. And this one is like you're going up a hill from left to right. So you want to note that. So in this question, you could see that one is positive and one is negative, right? So let's take off this. So M, here are the points. You can label them X1, Y1, X2, Y2. The gradient is Y2 minus Y1 over X2 minus X1. Y2 is 0 minus Y1, 3 over X2 is 6 minus X1, 0. We'll get negative 3 over 6. And when you cancel it down, you get negative 1 over 2. Negative a half. So the gradient for line L, is negative a half, which is the regular working out that you know, finding gradients. This is the formula. They're not going to give it to you. You have to know it for yourself. Find 2 points that are on the line, label them, and then you substitute. You get this. The fact that you get this, then you can prove the point to them. Let's go down there to prove the point. So let's write it. So the gradient for L is negative a half. Now, when they said show by calculation, they want you to do this that I'm showing you. So then this says the product. Product means to multiply. So this is saying if I multiply, I should get negative 1. Check it out. That's the proof. So whenever they're going to ask you to prove the perpendicular lines thing, you just need to have the gradient of the 2 lines. If you multiply them, you will always get negative 1. Always. And that only happens if the lines are perpendicular. If they are not perpendicular, you don't get that. So be careful, right? Careful. All right, so that's the proof. Can we now look at the next part of the question? Can we go?
Yes, sir.
Bring it down back a little bit, please.
All right,
Down,
you're writing
down,
up
down, no, down.
like this?
Yes, sir. Right there. Come on.
You want me to go more?
No, sir. That's all right. You can go, sir.
All right. Now let's look at this part. It says line, we're still under the same thing, you know. Right here, the E part. It says Line L and line M represent the graph of a pair of simultaneous equations. So you see, simultaneous equation using, very important, using the graph, not by calculation. Write down the solution of the pair of simultaneous equation. They said using the graph. So you see, anybody who want to try to solve it, it's not going to work. They don't want to do that. They said using the graph. So the only thing is you need to understand by looking at a graph and you see lines on it. What does the solution is? What is the solution when you're looking at graphs? Guys, whether you're doing simultaneous any graph, the solutions would be when the two graphs cross, as long as they cross path, like right here. This is their solution. So you need to make a note of this coordinate. That coordinate there is when 2 meets 2. This is an X and this is a Y. That's the solution, you know? You just need to look. Everybody can see where 2 meet 2 right there.
Yes, sir.
Where the 2 line cross path. So I just want you to understand, and this should be a 1 mark question. If it is there, if the mark, see, there is 1 mark, because they would know that there's nothing to do. So you look, you get the coordinate 2, 2. And it means that X is equal to 2, Y is equal to 2. That's your solution. You're done. So you look and you see it, you write it down and you move. Right? I remember I said to you, keep the point system. You'll know when there's a little working needed from when you snap your finger for the answer. All right?